Hello friends and welcome to YouTube channel Freedom Tech, and today we will learn how to use RF-DETR for custom object detection. We will create our own model and it will detect the number plate using RF-DETR. Simple. So for that, the files which I will use you will get from my shop, the Buy Me Coffee. I will mention the link inside description box. You have to simply click on it, just pay the small amount and you will get all the project folder. Also, if you are from India, I will mention the GPay link. You have to just click on that GPay link, scan the QR code and mention your Gmail address also. Then I will send the project folder to you on your Gmail address. Simple. So I have already downloaded the project folder. I will show you. This is the project folder. As you can see, right click and just click on extract all and it will extract the project folder. Just go inside, again same folder. And this is our Google Colab file. This is the code which we will use to run our custom model on the video file, and the video file name is basically tc.mp4, which is this is the video file. We will detect the number plate. Okay, simple. So for that we will use a RoboFlow universal data set. You have to just sign up with your Gmail account for RoboFlow. So sign up and then mention the RoboFlow, click on universe, and here we will search for number plate. Just search for number plate and click on hash train model. Just click on it, hash train model. Now it will show only the data set where we have the model, as you can see. So now just scroll down and the data set which I will use, which is this one, as you can see, this one. It has 300 images, one model, and the class name is basically license. Just click on it and this is the data set. As I mentioned, we have 300 images. So this is the data set which we will use. Now I need to open the Google Colab. So let me open Google Colab. So friends, I have opened Google Colab. Now just click on upload, click on browse and go to the downloads and our project folder and select the Colab file and just open it. It will upload our Colab file. So we successfully upload the Colab file. Go to the runtime, change runtime type, select T4 GPU, click on save and then just click on connect. We connected. Now we want to mention here our RoboFlow key. So for that, just click on RoboFlow setting. As you can see, configure API key. Just click on here, RoboFlow setting. It will open the new tab and then we want to click on this link, this one, setting API. Just click on it. It will open your API key which we have to mention. So this is the API key. Just copy it and go to the Colab, and here we have to click on this key icon, this one. Just click on it and we will create our new API key which I have already created, but I will delete and I will create new one. So just click on add new key and then we have to mention the name like this way, same way, RoboFlow. Then we have to mention underscore API and underscore key. This is how we have to mention the name, same as it is, RoboFlow underscore API underscore key, and in value we have to paste our API key. That's it. Done. Now we will basically configure our API key. So click on the cell and it will ask to access. So simply click on grant access. We have done. That's it. Now we will scroll down. Now we will cross check if the GPU availability is there. Simple. Just click on it. We have done with this cell also. Now scroll down and then we will install the dependencies. Just click on the cell. Then now we will upload the images. Scroll down. Now we will cross check the pre-trained model. As you can see, pre-trained model. Now we have done with the cross check. Okay, as you can see, this is the image and we have detection. Now scroll down. scroll down, and we will again install RF-DETR train and loggers. Just click on the next cell. Done. Now scroll down. Now here we want to upload our dataset. So open the dataset. As you can see, this is the dataset, and here we want to click on the dataset. This is the dataset. Just click on it, and we have to copy this link. Click on the dataset and copy this link. Copy it from universe. Copy like this way. Just copy it. Go to the collab, and here in double quote remove the old link and press Ctrl+V. It will paste the link, and then run the cell. It will upload the dataset inside our collab. So now if you click on this small folder icon, there is our dataset. As you can see, the number plate and all the files. Simple. So now scroll down. Okay, now here we will start our training. Just click on the cell. We will use epoch 10 and it will create our model. So now we will wait. So just scroll down, and here you will see the class name. As you can see, the class name is basically license, and epoch 0 is just started. So we will wait. So friends, we completed our training. As you can see, there is a green tick mark, so it means we successfully create our own model. Now we will run the next cell, then scroll down, evaluate, fine tune RF-DETR model. Just click on the cell, then scroll down, run the cell, next one. Then here, as you can see, this is the model. We will cross check. So this is the path. If you click on this small folder icon, and if you go in output folder, and our model name is basically checkpoint base total dot path, which is this one, checkpoint base total dot path. So this is what our model. Click on the cell. Okay, then the next cell, then scroll down, and the next cell again, then next cell, and then now here we will cross check our model using our dataset, one of the image. And as you can see, this is what our detection. So it means we are successfully detecting our license plate, license 0.85. So our model name is basically, as I mentioned, our model name is this one, checkpoint base total.pth. So checkpoint base total.pth is our model name. Just click on it and click on the download. It will download our model. So friends, as you can see, we successfully download our model. Now we will close the collab file, and if I open the file manager, downloads, and this is what our model. As you can see, right click, cut it, and go inside our project folder, and then paste it here. Now we will use here a Sony Python ID. You can use VS Code also as per your comfort zone. So I will go with the Sony Python ID. So main.py, open with Sony, and this is the code. This is what our code, and I have already mentioned the model name and the video file name. The model name we just created. Go to the tools, manage packages, and we will search for RF-DETR. RF-DETR, hit enter. Then first package, click on install, or if there is a upgrade, you can just install it and then upgrade it. I have already done. Now we will install OpenCV package. So OpenCV-Python, hit enter. First package, click on install, and then that's it. It will install OpenCV. Then we will install CVZone. So CVZone, first package, click on install button. That's it. It will install CVZone, and then we will install Supervision. So Supervision, hit enter. First package, click on install button. That's it. It will install Supervision. So we have done with the package installation. Also we will use here our tracker. So basically we will use a tracker from supervision. As you can see, supervision as SV, and from SV we have the tracker which is the byte track, right, the byte track, and we will go with the RF-DETR nano. Okay, so scroll down. As I mentioned, this is what the model, and tc.mp4 is basically our video file, and we will skip here 2 frame because I don't have any GPU, and that's it. This is basically the detection, and we are tracking here our object, means here our object is basically our number plate. That's it. Now just run the code. I think there is error, so let me cross check. So friends, error is solved, basically the path error for the model. So we have to mention the full path. So go to the downloads, our project folder, again same folder, and this is what our model. Right click and copy as a path, and here model is equal to, we have to mention our full model path like this way. Just copy it from here, copy as a path, and mention in a double quote as it is. Let me show you here how I have mentioned. I will remove the model path. Okay, so in double quote there is no R first. In double quote, when you get the file, only there is the model name, but we have to mention the full path, otherwise it will create the error. So I have just copy the path from the model, right click and copy as a path, and here just paste Ctrl+V and remove. There is a double quote, as you can see, means there is a 2 double quotes, so I will remove this one at the end, and here also remove this one. That's it. It's now green. Now it's perfect. Now only we have to mention here small r. That's it. Now save the code. We have done. We mentioned the path. We have our tracker. All the things are done. Now simply run the code. It will detect the number plate using our own custom model with RF-DETR. And as you can see, as I mentioned, number plate, because as I mentioned, this is the pre-annotated data set. If you want to create your own data set, you have to simply use your own video or images, and you can annotate the data set same as we annotate for YOLO, same way. Okay, so this is how, friends, you can create your own custom model with RF-DETR. Simple. So as I mentioned, the files you will get from my shop, the Buy Me Coffee shop. If you are from India, I will mention the GPay link. Just click on the link, send your Gmail address. I will send the project folder to you. That's it. So we'll meet our next video. Till then, thank you, take care, and bye bye.